Hi guys, today we are going to learn how to graph a system of equations and what it means to find the solution to a system. So what is a system and what is a solution? What does the solution look like? It turns out that if we have two or more linear equations involving the same variables, then that is a system of equations. This is what a system looks like. It's two equations with two variables. And when we put the bracket on the left side, it indicates that these two equations work together and form a system. Let me see what happened to my video. There we go. So the point of intersection is the solution to the system. And why is that? Before you answer the question, you want to look at an example. So we have two lines, and when we graph them, 3 comma negative 1 is the point of intersection. So why is this called the solution of the system? That's because each line has many ordered pairs on it. However, there is only one ordered pair that is the solution to both equations. And that particular ordered pair is the solution to the system. But when we have two lines, it's not necessary that those two lines will always intersect. So if the two lines do not intersect, then there is no solution. In fact, it turns out that they are parallel lines. Therefore, there is no solution. Sometimes when we graph two lines, it turns out that the two lines are the same line, and then there are infinitely many solutions. So here's when you graph it, it's the same line. So we say that there are infinitely many solutions. So how to graph a system? You already know this, how to graph it, but just a few reminders that you can use the slope-intercept form. And if you remember, the slope-intercept form looks like y equals mx plus b. The b is your y-intercept. It tells you where to begin. The m is the slope and it tells you how to move. Or you could use the x and y intercepts by creating a box like this. But whatever you do, you always have to graph points that are integers. You cannot graph any ordered pairs that have fractions in them. So keep that in mind. I'm going to go over two examples from your worksheet. So we have two equations here. We're going to take the first equation and you're going to isolate the y. So turns out that when you isolate the y in this case, um, the y-intercept is negative 1 and the slope is up 2 over 1. So you can start at negative 1 and then go up 2 over 1. You will draw the first line and label it. And then we move on to the second line. The second line is simply y is equal to negative 3, which happens to be a horizontal line at negative 3, and label that. And if you do this right, it turns out that the point of intersection is at negative 1, negative 3. And I want you to write POI as a short form for point of intersection. And that is the solution. Sometimes you have to use both methods. This is number 1 and number 11 in your worksheet. So let's look at the first equation and isolate the y. Turns out y is equal to x minus 3. And this you can easily graph with negative 3 as the y-intercept and the slope being positive 1. But the second equation, when you try to isolate the y, you get a fraction. You cannot graph the y-intercept as negative 3 over 2 because it's a fraction. However, we can use the slope that we get from here. The slope is 1 over 2. Since we cannot graph the y-intercept we need to find some other point. And I'm going to look for the x-intercept by making y equal to 0. If y is equal to 0, then x is equal to 3, which gives me the ordered pair 3, comma 0. And I can use this ordered pair 3, comma 0, and from there I can move up 1 over 2 till we have the two graphs. Remember to graph, label, and it turns out that the point of intersection for this one is 3, comma 0. And that is it. I'll see you in class. Goodbye.